So, hi. I have a code snippet. It's a general handler params function. It basically implements a basic filter. But there's an issue with it, and it resides right around here. We are generating atoms, and we don't really verify these keys, so someone can take down our node. What can we do with this? There are multiple libraries available that we can use. One of them is Sobelow, which is, according to GitHub, security-focused static analysis tool for Elixir and the Phoenix framework. It's open source, and it was designed to analyze Elixir and, more precisely, Phoenix projects. Another one is called Safe, developed by Erlang Solutions, and it's free for open source projects. It is capable of analyzing Erlang, Elixir, and Phoenix projects, and it uses a technology called data flow analysis. Basically, that means that Safe understands how the data flows in your program, and that can help reduce some false positives. And that is very good, because during a security audit, most of the time goes into manually reviewing all the results. And if the false positives are filtered beforehand, the whole audit will be much quicker and easier. So we wanted to compare these two tools. So what we did is we analyzed 7 open source products with these two tools. Together, they are around 80,000 lines of code, effective lines of code. That means that we don't count things like comments or documentation, but really the lines that are actually running. And here are the results. So both tools actually found many vulnerabilities, potential vulnerabilities. Safe found 90 of them, and Sobelow found 77. Then we filtered these vulnerabilities by hand, and we found false positives. We found 7 in Safe's results and 19 in Sobelow's results. If you check the vulnerability categories, we can see that most of these vulnerabilities are either denial of service or cross-site scripting vulnerabilities. Just to check some examples, so denial of service vulnerabilities in Erlang and Elixir usually happens when we are generating atoms, but we don't really verify the value beforehand. So this example is pretty much the same as the previous one. We are generating atoms from keys coming from the client side, but we don't really verify these values. So we should have a whitelist of these values beforehand. So yeah, there are no vulnerabilities. The other common category was the cross-site scripting. This can happen when a malicious attacker can inject runnable code on other clients' browsers. By default, Phoenix is very safe, and it doesn't let anyone do that. But there are some escape hatches that can be used sometimes in very special cases. For example, in this example, we are trying to show a comment, but we wanted a comment to have rich text. So a naive way for this to enable users to use HTML in their comment. The issue is that HTML also has a script tag, and if you don't filter that, then other users might have random code running on their browsers. So it's very important to filter the inputs beforehand. Going back to the results, we can see that Safe actually has 8% false positive ratio, whereas Sobelow has 25%. As I said before, this is very useful during security audits because it's much faster, much quicker to filter these results by hand. Thank you.